Alright, so one of the problems we realized that you need, that was on the test that maybe you had troubles with, was 2t over 1 minus 1 over t. And so if you ever have to add or subtract fractions, first off, know that you cannot cancel these. You can only cancel these if it's a multiply in the middle, but this is a subtract. So you cannot cancel these. What you do need to do is get a common denominator. So we'll multiply top and bottom by t. And so now when we multiply this out, we get 2t squared, and then minus 1 all over t, because it's my common denominator, so I'll just leave that as t. And this would be your answer. Another thing that we know you need to look at is if you have, let's say, the cubed root of x, y, z cubed, and then you don't need a cube root that, you don't need, because those are only one of them. What you're looking for when you're doing a cube root is groups of 3. And so since there's 3 of those, we can take the cube root. And so when we take it out there, basically what you're doing is you're taking the exponent divided by the root. And so 3 divided by 3 is 1. And then you're still left with the other stuff inside the cubed roots. So the cube root of xy. We can make that a little bit more difficult and do another problem where you have the cubed root, and now we've got a mixture of things, 8 x squared, y to the 8th, z to the 7th. And then I can cube root some of these. I'm going to simplify it out. I can cube root the 8, because that's just 2. The cube root of 8 is 2. X squared I cannot cube root, because there's not 3 of them, there's only 2. Y to the 8th, as an 8 I can't cube root, but if I had a 6, then I could cube root, because there's 2 sets of 3 y's in there, but then I still need it to be y to the 8th, so I need a y squared in there. And then z to the 7th, I'm going to go z to the 6th, and then z to the 1, and I can cube root z to the 6th. Then I can simplify it, and all of these need to come out here, so the cube root of 8 is 2. If I want to cube root y to the 6th, I'm going to take the exponent divided by the root, so it's going to be z squared. No, sorry, that's a y. It's going to be y squared. And then the same thing with the z. I'm going to have a z squared, because 6 divided by 3 is 2. And then I'll be left with the cube root of x squared. So I'm just writing what's left inside the root, y squared, and z. Okay, if you were given a crazy fraction inside the, so let's say you had the cube root of 8y cubed over 4y squared, what you first want to do is simplify inside the square root first. So like 8 and 4 can simplify, 4 goes into 8 twice. And then also we can subtract exponents here, 3 minus 2, and that would be there. So now I have the cube root of 2, and then 3 minus 2 is y to the 1. And I can't do any cube roots there, so that's going to be my answer. Okay, another problem is if you have a complex fraction, and I think some of you had quite a few of these. So now with a complex fraction, if I just focus on the top, I know I need to get a common denominator. So I'm going to put this over 1, and then I get a common denominator taking y times y on top and bottom. And so now on the top of that we get y plus 3. On the bottom it's just a y. And then it'll be 5 over y squared. And now I have a fraction divided by another fraction, so I'm going to multiply by the reciprocal. So y squared on top and 5 on bottom. So then we can cancel, because we have a multiply here, I can cancel the y and then one of the y's there. And the y's are not going to cancel here because of that plus in the middle. It's only if there's multiplication going on. So now on the top I'm going to have y plus 3 still, and then I have that y over 5. And then they might take the y and multiply it through. You're going to have to look at the answers that they gave you and see what matches up. Okay, another question that might come up is perpendicular lines. So if you have y equals 1/2 x plus 5, and you need to figure out the perpendicular line, first off, your slope, which is this guy right here, is going to flip it over and change the sign. And then you're going to have to figure out b. you have to figure out what b is, because they're not necessarily going to be the same. If I look at the graph here, okay, if I graph 1/2 x plus 5, and the other one's going to be perpendicular, it might be over here. And so it's going to have a different y-intercept way up here that is not the same as the y-intercept on the other one. So you're going to, if they give you a point that's on that line, then you're going to plug in your 2 for the x, and you're going to plug in your 3 for the y, and then you can have the equation of the perpendicular line. Another thing that was on there that some people forgot about was composition. So let's say you have a function, f of x equals 2x plus 5, and then you have another one, g of x equals x squared minus 1, and you're supposed to find f of g of x. Well, first off, I want to point out, here's f of x, here's f of g of x. If you look, the f's are the same. What's different is what's inside the bubble. Inside the bubble here is just an x. Inside the bubble here is g of x. What that means is wherever you have an x, you're going to have to take all of g of x, all of this, you have to plug it in for x, because we replaced the x with g of x. So what I'll do is I'll look at the outside function here, f of x, and I'm going to take that, I'm going to write it down, only instead of x I'm going to put a bubble, because remember I'm going to replace that with g of x. So I'm putting a bubble so that I have room for it. So it's still the same thing here, only instead of x I put a bubble. Now in that bubble I'm going to put x squared minus 1. So now that I have x squared minus 1, I just have to do my math now. It's just a matter of multiplying through by 2 and then combining like terms. So 2x squared plus 3. And that would be the composition of that. So it's really not that bad if you understand that you're just plugging one in for the other. Okay, another was that you have this graph that you've probably never seen before. And you have to identify whether or not it is y equals x squared, y equals 1 over x, and y equals 1 over x squared. Okay? Now, here's what I suggest. If you don't realize it, well, first off, you should realize that this one right here is a line that goes like this, so it's definitely not it. This one's a parabola. Parabolas go like this, so that's definitely not it. So we can cross 2 of them off right away. But these last 2 are ones that we really haven't done much with. So what you can do is, you don't have to know what those are, you can set up a table for each of them. And so if I set up a table for the first one, if I plug in 1, that would be 1 over 1, which is just 1. So I could see where if this was 1 and this was 1, they kind of match up right there. So that might be okay. If I plug in 2, I get 1 over 2. Well, that's 1/2. So if I plug in 2, could that be 1/2? I think it could be. Okay, so on the positive side, this looks good. What about on the negative side? If I plug in -1, then I get 1 over -1, which is -1. So if I have 1, then y would be -1. Could that be that point? It could. So far, everything's matching up. And so this one actually might be the answer. But I want to rule out the other one for sure. So then I look at the other one and I say, what if I plugged in 1? I'd get 1 over 1 squared, which is just going to be 1 again, so that matches up all right. How about 1 over 2? I'm sorry, what if I plug in 2? Then I get 1 over 2 squared. That gives me 1 over 4. Now, I don't think this is 1/4, but you know what? It's really not easy to tell. So let's go to the negative side and see what happens. Now I get 1 over -1 squared, which should be 1 over 1, which is a positive 1. So when x is -1, y is a positive 1. That definitely doesn't match up. And if I did -2, it would be 1 over -2 squared, which is 1 over 4, positive 4, so then it would be right here. So really, this bottom one, the graph would look like this. So they'd be on either side, but 1 over x gives me the pink one. So I'm going to have to say that it's 1 over x. And even if you didn't know that this was linear and this was quadratic, you could set up a table for each of them and just see if they match up. So really, a table can be very helpful for you in this one, because you could figure it out without actually knowing anything about the actual graphs there. Okay, another question was 3 equals 24 over the square root of p, and I'm guessing what you had to do on this one was solve for p. Well, what I don't like is that p is in the denominator, and it's never good when your fraction's in the denominator, so I'm going to multiply both sides by the square root of p. So then these guys cancel out and I get 24, and then I'll put the 3 in front of the square root of p because that's how it's supposed to be. And then I divide by 3 on both sides. So now I'm just solving for p. Now it should be pretty easy. Square both sides, so p equals 64. And it really wasn't that bad once you got p out of the denominator. Okay, and lastly, this will be our last one. If you're told that y equals 4, and you're told that y equals the square root of x, and you're supposed to figure out that they intersect at a comma b, and you're supposed to find out what a is. Okay? Well, a is just the x values, so basically what we're trying to do, so I had to pause it for a second, but basically when you look at this, you guys, you have two equations. You have this one, which is really simple, you have this one, which is a little bit scary, but you have two equations. And so these y's are the same thing. That's going to be the b value, these y's, and actually we can already tell it's going to be 4. b is 4. So now we have to figure out the x value, and if you think back to our substitution elimination, we can just take what y equals and plug it in for y. So now I have the square root of x equals 4, and now all I have to do is get rid of the square root, and x equals 16. And so the x value, which is a, is 16, so a equals 16.